Hello, I'm Howard Schechter, proprietor of the Perfect Edge, a business I started about 22 years ago. And we sharpen and we hone all kinds of blades and tools. And one of the questions that often comes up um, is how hard is the steel that I'm using? So I often hear people talk about this and really talking about it in relative terms. Um, in industry, what we actually use are standard hardness scales. There are quite a number of hardness tests. The most common is the Rockwell test, invented by Stanley Rockwell. Um, there was the Brinell hardness test. There are quite a number of them. And in knife making, we typically use the Rockwell test, and we use a machine called a Rockwell tester. And what it does is it has a diamond point, and you put the piece of metal into the machine, and you pull a lever, and it drops the diamond point with a known force into the steel, and you compare that dimple to the dimple made by the same machine at the same force on a test biscuit of known hardness. And hardness is a very interesting property of steel because it's not an inherent property of steel. Um, it's relative, and all hardness measures are relative. So you can measure hardness, but really what you'll be able to say is this is harder than that, or that's softer than this. The most important part to know is whether or not your heat treating process is actually working. Now, in the straight razor industry, we get a lot of blades. This one is from China. You'll know it very well. It's a gold dollar, and they're very common. They've improved greatly over the past few years. They used to be pretty sketchy, but now they're pretty even quality. The Chinese have learned. I've gotten razors in from Pakistan, and depending on who's making them, they're either very sketchy or they can be good. The Pakistanis are definitely learning, and they want to produce a better product, and they want to be competitive in the American market. And I've worked with them and helped to improve their quality in a number of ways. The Stanley Rockwell scale measured on the Rockwell hardness tester is usually done on flat pieces of steel. So if the piece of steel is on an angle, or if it's very thin, you have to use either a special Rockwell tester called a superficial tester, or you have to use some other way of doing it. Now, with straight razors, we've got another problem, which is that when you make a straight razor and you pull it out of a kiln at about 1800 degrees, 1600 degrees, whatever is specified for that particular steel, it's red hot, and you plunge it into oil to quench it and freeze the molecular structure so that it's at maximum hardness for that particular type of steel. Then we take it and we put it into another type of oven, and we bring it up to the tempering temperature. And this is a very deep study. There are people who specialize on this all their life. Austenizing, tempering, annealing, normalizing. This is a huge study. It's not simple at all. And even in commercial heat treating factories, results aren't always what are expected. So it's as much art as it is science, and there's a lot of science to it, but you don't always get the results that you have intended to get. So that's why we test. So An easy way to do that with straight razors is by using hardness testers of known hardness made by a quality manufacturer. And you start out at the lowest, in this case, well, this one is a 64. So this is a 50 Rockwell hardness. Now, I always know when people are new to the hardness testing game because they go, oh, that's a 62 Rockwell. In industry, it's never like that. It's always, oh, this will be 56 to 58 Rockwell. And that's because there's variation in the testing. There's always variation. Remember, this is not an inherent property, so it can't be absolutely guaranteed. So you're given a range. And when somebody doesn't give a range, I know that something's going on, okay? So with the straight razors, what I do is I test right over here at the heel where it's not going to affect the working portion of the blade. Now, the hardness on a straight razor is different from here to here to here. It makes a difference when you quench it, how quickly it cools, and what exactly is going on in the steel. This is why I'm a minimalist honer. I don't want that edge to go back into softened steel or steel of a softer hardness before it's time. And if you are constantly killing the edge, and this is a new practice that has horrified me, there are some people who, when they get a razor, what they do is they take it to a stone and just take the edge down so that it's flat. And you're taking off a lot of steel when you do that. You will prematurely age a razor and shorten its life consequently. I don't recommend doing that, and I've heard the rationales for it. Oh, you know, when you get a razor that's been stropped, it's been worked back and forth, and it's not the molecular structure is not good, so you got to remove it. You don't have to remove it. If you just bevel it and go up the progression out to 30,000, you'll stay in good steel, and it'll be a good sharp razor that'll stay sharp for a long time. So the conundrum is you don't want to take this sharp edge and go in to the edge, because then you're going to have to take off more steel. So I get as close as I can on the heel, and this one just skates right over the steel. And I think we said that was a 50 Rockwell. So let's try, this is a 58, okay? We go down there, we go to the same place. No, it's still skating. This is a Wade and Butcher from Sheffield, England. This is one of my favorite razors. They're great razors. Okay, so let's try a 60. No, the 60 is still skating. All right, so let's try a 62. There's a 62? No, that's a 52. Let's keep this organized. Here's a 62. Okay, that one is biting into the steel. It's not skating. All right, so I know that this razor is a 60 to 62, could be 61 Rockwell, and that tells me something. It was heat treated well, and somebody checked it, because every Wade and Butcher I have ever tested has always been 60 to 62. So I carry these on my website. You know, you can get them elsewhere on the web as well. There's a smaller set, which is fine for razors. They're cheaper because there's fewer of them. These are precision tools, so they're not inexpensive. And if you're really interested in hardness, and it's another measurement of straight razors that's useful to know, then by all means get into some hardness testing and check it out. Now, what is the practical value of it? The practical value of it is when I get a razor in, as soon as I start to set the bevel, I can feel whether it's hardened or not. And if it's not hardened, it feels gummy on the stone. And if it's gummy, I can go through the whole progression from bevel setting to 30,000 right through to finishing on the construction. I'll get a great edge, but it's not going to last very long. And this is a general principle. I mean, I can take a credit card and I can sharpen a credit card and I can go to a top round piece of meat and I can slash that piece of meat and I'll gash it open. But I won't be able to do it a second or third time. As credit cards don't hold an edge. And unhardened and untempered steel doesn't hold an edge either. So it's very important that you test to know exactly what you're dealing with. Now, there are razors that I have gotten in which I know are quality razors. I've tested similar ones and known they're hard, but they're untempered and something happened. And usually what happened is somebody sharpened it on a belt sander or some type of mechanical device. I've even fixed ones that were put on bench grinders, which is a definite no-no. And I've seen these people advertise on the web. They go, oh, we sharpen straight razors for $5. And it's like, there's no way you could sharpen a straight razor for $5 and not hurt the straight razor. So it's important to know hardness. It's fun to know. It gets you into a good feel for the quality of how the blade was made, and I highly recommend it. So especially if you're going to get into forging straight razors or making knives, which is a fantastically fun endeavor to do. Completely frustrating, very difficult. You will cut yourself a lot, and ultimately you'll come out with a tool that's really something to be proud of. So that's testing the hardness of straight razors.